the specific heat capacity of a liquid or solid by the method of mixtures. Introduction. The specific heat capacity of a substance is the amount of heat that must be transferred to a unit mass of the substance to raise its temperature through 1 degree Celsius or 1 Kelvin. The SI unit of specific heat capacity is the joule per kilogram Kelvin, while the CJS unit is calorie per gram degree Celsius. The method of mixtures in calorimeter is derived from the law of conservation of energy. When a body at higher temperature is brought into thermal contact with a body at lower temperature, there is transfer of heat from the hot body to the cold body till both of them attain the same equilibrium temperature. If there is no loss of heat to the surroundings, the heat lost by the hot body is equal to the heat gained by the cold body. Aim 1. To determine the specific heat capacity of a liquid using a solid of known specific heat capacity by the method of mixtures. 2. To determine the specific heat capacity of a solid using water by the method of mixtures. Apparatus: a beaker, a calorimeter with stirrer, a thermometer, a digital weighing balance of precision 0.01 gram, a small piece of metal, given liquid whose specific heat capacity to be known, a piece of thread. Part 1. Determination of the specific heat capacity of a liquid. Procedure: fill the beaker 2/3 full of water and start heating. By the time the water starts boiling, weigh the given piece of metal using the balance with precision up to the 100th part of a gram. Record the observation. Observations: mass of the solid M is equal to 100.45 grams. Weigh the empty dry calorimeter with stirrer. Note the observation. Mass of the empty dry calorimeter with stirrer M1 is equal to 120.68 grams. Fill the calorimeter to about half its capacity with the given liquid, say tap water for simplicity, and weigh it again. Note: mass of the calorimeter plus stirrer with the liquid M2 is equal to 231.41 grams. Therefore, the mass of the liquid taken, ml, is equal to M2 minus M1 is equal to 115.73 grams. Place the calorimeter inside the insulating box, which is shielded from heat radiation. Tie a piece of thread to the metal piece for convenience in handling. Suspend the solid in the boiling water for 15 minutes. Note the temperature of the boiling water using a thermometer. Record it as the initial temperature of the solid. θ1 is equal to 100 degrees Celsius. Remove the thermometer from the boiling water and cool it holding in a stream of tap water. Dry it and insert it into the calorimeter. Note the initial temperature of the calorimeter and liquid. Initial temperature of the liquid and the calorimeter, θ2, is equal to 29 degrees Celsius. Take out the solid and quickly dry it using tissue paper and transfer the hot solid quickly into the calorimeter and cover it with the wooden lid. Gently stir the liquid. Note the maximum temperature attained by the mixture, calorimeter, stirrer, liquid and solid. theta is equal to 35.5 degrees Celsius. Find specific heat capacity of the given solid and the material of the calorimeter and stirrer from data book and note. Specific heat capacity of steel CS is equal to 0.12 calorie per gram degree Celsius. Specific heat capacity of the material of the calorimeter plus stirrer C is equal to 0.09 calorie per gram degree Celsius. Let us calculate the specific heat capacity of the liquid by applying principle of heat exchange. Formula and calculations. Heat lost by hot solid is equal to heat gained by the liquid plus heat gained by the calorimeter and stirrer. MCS, the whole bracket theta 1 minus theta is equal to MLCL plus M1C the whole bracket into theta minus theta 2 the whole bracket. Therefore, CL is equal to MCS into theta 1 minus theta the whole bracket upon ML into theta minus theta 2 the whole bracket minus M1C upon ML. Let us substitute values of various terms and calculate the value of specific heat of the given liquid. Therefore, CL is equal to 100.45 into 0.12 into the whole bracket 100.0 minus 35.5 upon 115.73 into the whole bracket 35.5 minus 29.0 minus 120.68 into 0.09 upon 115.73. Using logarithmic table for calculations, we find specific heat of the liquid in the calorimeter. CL is equal to 0.94 calorie per gram Kelvin. Hence, specific heat of the given liquid is equal to 0.94 calorie per gram Kelvin. Thus, knowing the specific heat of the solid, the specific heat of the liquid used in the calorimeter can be found out experimentally. Results. The specific heat capacity of the given liquid is equal to 0.94 calorie per gram degree Celsius. Part 2. Determination of the specific heat capacity of a solid. Procedure. In the second part, specific heat capacity of a solid is found using liquid of known specific heat. For this, clean water is used in the calorimeter. Same procedure as in the first part of determination of specific heat of solid carried out. And the specific heat of the solid is calculated using formula CS is equal to the whole bracket MWCW plus M1C into the whole bracket theta minus theta 2 upon M into the whole bracket theta 1 minus theta, where all symbols have same meaning as in part 1. Notes and precautions. 1. Dry the solid and empty calorimeter before weighing. When weighing the calorimeter with liquid or water, dry the outside of the calorimeter. 2. Keep the calorimeter along with its contents in the insulating box shielded from heat radiation 3. Cool and dry the thermometer before inserting it into the liquid or water in the calorimeter.